Okay, so in this video, we will talk about how to solve the higher order ODEs. So a higher order ODEs means suppose we have this d to u over dt square function of u du over dt comma t. So since the order of this equation is 2, so this is called higher order ODE. If order is greater than 1, then we will call it higher order ODE. And the boundary conditions which are given for this higher order ODEs is that at t is equal to 0, u is equal to 0 and t is equal to 0, du over dt is equal to v naught. So you can call it u naught and v naught. These values are given and we need to solve this higher order ODE. So the procedure is that we will reduce this higher order ODE to several single order ODEs, and then we will follow the procedure used for system of ODEs which could be linear or non-linear. So this is how we will approach this kind of problems. So let me try to show that how this higher order ODEs, that is having the order of 2, can be converted to several single order ODEs. So we have d2u over dt square, that is function of u du over dt comma t. So my first ODE is that du over dt is nothing but v, and it's given that v at t is equal to 0 is equal to v naught. So if I do this, this is my first ODE, and if I double it, do the derivative one more time, then d2u over dt square will become dv over dt. That essentially means that my dv over dt is nothing but function of u comma v comma t. So for this equation, the initial condition will become u at t is equal to 0 is nothing but u naught, and for this equation v at t is equal to 0 will become v naught. So this is my second ODE. So what we have, that d2u over dt square, which has fu du over dt comma t with u at t is equal to 0 is equal to u naught, that is u naught, and v at t is equal to 0 is nothing but v naught. So this gives me two ODEs. First ODE is du over dt is equal to v naught, v, and it's given that u at t is equal to 0 is equal to u naught. The second ODE is dv over dt is equal to f u comma v comma t, where v at t is equal to 0 is nothing but v naught. So this becomes my system of two equations. So suppose if the order is 3, then we will get 3 equations. Now depending upon this f, it could be linear or non-linear, so we will follow the procedure which was discussed in the system of ODEs. So let me give you this example, that is suppose there are, the equation is d3u over dtq is function of u d2u over dt square du over dt comma t, where it's given that u at t is equal to 0 is equal to u naught d2u over dt square at t is equal to 0 is equal to w naught, and du over dt at t is equal to 0 is equal to v naught. So to convert this into several ODEs, first I will take du over dt is equal to v. With this I see u at t is equal to 0 is u naught. This is my first ODE, and I will take the second ODEs as dv over dt is equal to w. IC is v at t is equal to 0 is equal to v naught, and the third ODE will become dw over dt is equal to f of u w f of u w p comma t, with w at t is equal to 0 is w naught. We remember that dw over dt is nothing but dv over dt is equal to d2u over dt square. So this is my so this is just for your understanding, and this becomes my third ODE. So this is how we can convert, and we can use the system of ODEs to solve this kind of uh, to solve this system. So we have 1, 2 and 3 ODEs coming out of this single ODE which is having higher order. So this is how we will approach. Thank you.